So we just did a video on 9 questions on simplifying. We have 10 questions on solving, and you could factor when you solve, or you could also use a quadratic formula when you solve. Actually, you could use a quadratic formula on any equation when solving, but it's not the best or quickest method. The first thing you should try to do is factor. So we have, I cut all from the test, from the practice test, I cut all the ones that I saw solving quadratic equations on, or also factoring. So we're going to focus on this video on factoring and solving, and let's begin by just doing some. So whenever they ask you to solve and you don't see a number out here in front of the h squared or the x squared, when your a value is 1, it's always a great idea to try to factor. And on many of these on the test, you will be able to factor by setting this up and thinking what times what is negative 18, that if I combine together gives me a positive 7. And you'd be like, oh, that's positive 9 times negative 2. And then all you have to do is understand that this is something times something equals 0, so you could split them with the zero product property. And of course, you could solve each of those, and you'll get h equals negative 9, h equals positive 2. Those are your two answers. So it's that easy. Now there's, like I said, 10 questions. Right here, this is the biggest bang for your buck right here, where if you want to study anything, study solving by factoring. And if for some reason you cannot factor, like on this next one, they ask you to solve this quadratic equation, always remember to set it equal to 0 first. So if you subtract 6x and subtract 6x, you could rewrite it, and you'll get 3x squared minus 6x minus 4 equals 0. Now, if you did try to factor, you'd have to use the long method. Step 1 would be to multiply a times c and get a number like negative 12. And then you got to think of the multiples of that number, negative 12, that combine together to give you the b value. Now, that's a long process. The fact is, the a value is not 1, it's 3. So you could try to factor. It doesn't mean it is factorable. It might not be factorable. So if I see a number out here and I know that it's not factorable, I jump right into the quadratic formula. So we need to have that quadratic formula memorized, and we need to know how to use it. We're going to replace those variables with parentheses. And of course, we need to identify the a value, the b value, and the c value. And let's plug in b, negative b, which is negative 6, plus or minus the square root of b squared, negative 6 squared, minus 4 times a, which is 3, times c, which is negative 4, all divided by 2 times a, which is 3. And when we have this, we should begin with our discriminant value. So moving that to the side, we're going to begin with the negative 6 squared. What's negative 6 squared? Anybody? 36. All right, so we have 36. And then we have 4 times 3, which is 12, times 4, which is, what do we have there? 48. So we really have plus, because a negative times a negative is a positive, 48. So we have a 36 plus 48. Let's write that in. Now remember, this is just our discriminant value, and when we add 36 plus 48, we get 84, right? 84. So we really have the minus 6 becomes positive 6, plus or minus the square root of 84 divided by 6. And as you can see, the 84, the discriminant value, 84, is not a perfect square number, so we're not going to get nice answers. So this problem is not even factorable. So that's why I always try to factor first, but it's not even factorable, so you're forced to use a quadratic formula. When we think about 84, if we do that on the side, the square root of 84, we need to try to break it down with multiplication to get a perfect square number. And if we go with the first perfect square number, 4 times what is 84? I believe that's 21. So when you split the root, you really will get 2 square root of 21. So the square root of 84 is really 2 square root of 21, and we're going to replace this square root of 84 with 2 square root of 21. So we really have 6 plus or minus 2 square root of 21, all divided by 6. Now, the final part that a lot of students forget to do, they think that they're done right here, and they look for the multiple choice answer, and it's not there. The reason is you have the 6 here, the 2 there, and a 6 down here, and they're all divisible by 2. So in other words, you could reduce this ugly looking fraction. You could reduce it all by 2. So if you reduce it all by 2, that becomes a 3, this becomes a 1, this becomes a 3. So let's rewrite our final answer. 3 plus or minus 1 square root of 21. Notice that I don't have to write the 1 in front of the square root of 21 over 3. So this blue one would be the final answer that you have to find on the multiple choice part of the test. Okay. So another clue to use the quadratic formula on this particular part of the test is that your answers on A, B, C, and D, it's going to look like this, and that should remind you to use the quadratic formula, right? Now, if all of your answers on A, B, C, and D are nice numbers, like x equals 2, x equals 3, x equals 5 and 7, x equals negative 1 and negative 5, if you have nice answers instead of these ugly ones, then you know it's factorable. So you might as well go with factoring, not the quadratic formula. Let's move on. Now, some questions are just going to ask you, factor, right? Just straight up factor. So right there, again, there's no a value in the front. The a value is 1. Anytime the a value is 1, it's super easy. You just set up this format and you think what times what is the c value that if you combine together is a b value. Now, if you're struggling with this, make a list. How could you get 28? Well, there's 1 times 28. There's 2 times 14. There's 3 times, 4 times 7. And that's about it. So out of those 3 possibilities, which pair of numbers combines together to give us the b value, negative 11? Well, the 4 plus 7, that'll give us a positive 11. So we know we have the right number, we have the wrong sign. That means that the 4 and the 7, those are the right numbers, they just have the wrong signs. So put a minus 4 and a minus 7, and there's your factored form answer, g minus 4, g minus 7. These are easy questions, guys. All you have to do is review. So we have another factor completely question right here, but I'm not going to do it. We just did one of these, too easy. We have another quadratic formula. Again, when you look at your multiple choice answers, you're going to see that there's going to be a plus or minus square root value in a fraction form. So that's like a hint for you to use the quadratic formula. It won't tell you use the quadratic formula. It'll just say solve. But if you see your multiple choice answers and all the answers are not nice answers, if they have a root right there, a square root with the plus or minus in front of it, you know you're going to be using the quadratic formula the way we just did a little while ago. So we already did one of these. I'm not going to do it again. Solving. Is this easy or difficult, this one right here? Easy or difficult? What do you guys think? Easy. Why is it easy? Because the a value is 1, right? Which means that all you have to do is set it equal to 0 and then factor, right? So let's do that since it's so easy. Subtract 84. Subtract 84. We have a new equation. K squared minus 5k minus 84 equals 0. And then you could set up the factored form. Why could I set that up? Because a value is 1. So k times k is k squared. Okay, so now the trick is what times what is negative 84 that if I combine together is negative 5. If you're confused, make a list. So I was making the list and I got to the number 3 and I'm not sure 3 times what is 84. So I did it on a calculator. I went 84 divided by 3 and I got 28. Let me try 4. That is negative 4 times 21. 5 is not going to work. Maybe negative 6. Let's see. 84 divided by 6. Negative 6 is 14. Okay, so with the calculator, all this becomes easy. We also have negative 7 times 12, and that's about it. So out of all those possible combinations that multiply together to give you negative 84, the pair of numbers that does give you the middle value when you combine them is almost this guy, right? If you combine negative 7 plus 12, it gives you a positive 5, and we know we want a negative 5. So we have the right numbers, just the wrong signs. So we're going to change that to a positive 7 and a negative 12. Put a plus 7 in there and a negative 12 right there. And when you split them, you'll have k plus 7 equals 0. K minus 12 equals 0. So your two answers are k. Why did I put k equals negative 7 and k equals positive 12. Those are the two answers for that one. This question's equally easy, but I don't want you guys to freak out. Understand what it's asking, right? It says one of the factors of this quadratic trinomial is one of the following, right? So I know a lot of you guys are going to get confused. Just think of this. Here's a quadratic trinomial equation. There it is. Let me box it in so you can see it. And they want you to factor it. That's it, right? So let's factor it. What times what is negative 24 that if you add together is negative 2? Come on, people. Help me out here. What times what is negative 24 that if you add together, that if you combine together is negative 2? 4 and 6. Which one's positive? Which one's negative? The 6 is negative and the 4 is positive, right? Okay, so do you know how to factor it? Yes. But they don't give you the answer as what the factored form is, x plus 4 times x minus 6. They ask you which one of the following is a factor, right? So is there an x plus 4 anywhere? I mean, we're going to look for the first one, x plus 4. It's nowhere there. Is there x minus 6 anywhere? No, it's x minus 8. Nope, nope. So what do we say? We say none of these, right? So in this case, it would be none of these. By the way, there is no option E. There is no option E on the final exam. So it will be one of those, and you just have to find out which one it is, right? Factor completely. Those are fun. Sometimes on factoring completely, you could continue factoring on the inside. So we always try to do what first? What kind of factoring? What's the first type of factoring that we learned, which is the first type of factoring we should always try to do? GCF. Thank you very much. Now, what is a GCF in 7v squared and 63? 7. If you pull out a 7, what do you have left? V squared minus 9. And that's it. Now, there will be a multiple choice answer that looks like this, and it's wrong. Okay, so if you circle that one, it's going to be wrong. Now, why is it wrong? Because this is not completely factored. This is only partially factored. In other words, you could look at the inside of the parentheses, which is v squared minus 9, and you could continue factoring. The fact is you have a perfect square term here and a perfect square term there, so you could actually square root to do that shortcut. Or you could think of it as, okay, v squared, there is no middle term, so you could put a 0v if you want, and then minus 9, and then you could think, okay, what times what is the c value that if I combine together is the b value, which means that there is no b value, which means 0. So what times what is negative 9 that if I combine together is nothing? That would be a positive 3 and a negative 3. And then you bring down the 7 out in the front, and there's your final factored form, completely factored form answer. So that one's pretty easy as well. You pull out the 7, and then you continue factoring on the inside. Some say factor completely, but all there is to do is pull out the GCF. So what would the GCF be right here? We have 36, 54, and 18. Now you might be thinking I could pull out a 2, and yeah, that's correct, but there's still going to be greater values. Let me pretend that I don't know what I'm doing, and let me pull out a 2. All right. If I did pull out a 2, you would have an 18. You would have a minus 20. What? 7, and you'd have a plus 9, and of course you still have the j to the 4th, the k, the j to the 9th, and the k to the 7th, and the j to the 4th. But as you could see, on the inside, you still have 18, 27, and 9, so you could pull out a 9 as well, right? So, in other words, your GCF, if you do pull out a 9, because 18, 27, and 9, they all have a 9 in common. If you pull out a 9, that means that your original GCF should have been 18, not 2, right? So let's go back and let's pull out the 18. And let's also look at the letters. There's j to the 4th there, j to the 9th right here. And over here there's another j to the 4th. So from all three j's, what's the maximum amount of j's I could pull out? J to the 4th. So I'm going to put 18, j to the 4th. And how about k's? There's a k here, there's 7 k's here, but there is no k there. So there's no k's that I could pull out of all of them at the same time. So my GCF is not 2, but it is truly 18j to the 4th. So when I think 18j to the 4th times what will give me a 36j to the 4th k? Well, 18 times 2 will give me 36. The j to the 4th j to the fourth times 1 is j to the fourth, but I also need a k, so I need to put a k down here. So 2k is my first term. Then I go 18j to the fourth times what will give me this middle term. Starting with the 18 times what is negative 54, that would be 3. So minus 3. And then, of course, j to the fourth times what gives me a j to the ninth. So right there you would have a j to the fifth, because j to the fourth times j to the fifth is j to the ninth. You have to add right there. And we still need this k to the seventh, so let's put it down right there, k to the seventh. And last but not least, 18j to the fourth times what is 18j to the fourth? Well, that would simply be a 1 right there. 18j to the fourth times 1 is 18j to the fourth. And that's all there is to do. You can't continue factoring on the inside. So that's it for that one. The last type of question says, what are the x-intercepts of the function? And if you guys remember, to find the x-intercept, you set y equal to 0. So this f of x, this is really a y. And if you set it equal to 0, it'll be the quadratic trinomial equation, 3x squared minus 5x minus 7 equals 0. And you need to solve that thing. So that's another one where you could use a quadratic formula. I mean, you can't even factor it. Even if you tried, it wouldn't be factorable. So you use the quadratic formula. There's a quadratic formula. There's my quadratic formula with parentheses. My a is 3, my b is negative 5, my c is negative 7. So I have negative 5, 3 right here, and c negative 7 right there with the 3 down there. We have negative 5 squared, that is 25. We have 4 times 3, which is 12, times 7, which is 84. And a negative times a negative is a positive, so plus 84 is what we have. And 25 plus 84 is 109. So let me rewrite my quadratic formula question here. The positive 5, because a negative and a negative is a positive, plus or minus the square root of 109 divided by 6. Now you're supposed to try and take the square root of 109, and if you can't do it, which you can't, you need to try to break it down with multiplication to get a perfect square number. That way you could continue reducing. But 109, you can't even break it down by 2 or by 3. It just does not work. So that's as far as you could get, and this will be your multiple choice answer. So right here we've done all the solving equations, quadratic equations. On some of them we did use the quadratic formula, like on this one. When the a value is when the a value is 1, like right here we had a value of 3. When the a value is 1, always try to do factoring. Factoring is really easy. Factor, split it, and solve it. But when you have an actual number right here, you might as well use the quadratic formula. It always works. Okay? And that's 10 questions. So that's a huge chunk of the test. So we're talking about over half of the test, guys, is on this video, which is factoring and also solving with the quadratic formula. And remember the other video of simplifying. Just with those two videos, you have over half of the test.